Alright, so in this calculator lesson, we are going to determine a regression function for data that we're putting into lists in the calculator. First of all, a regression function is the best explanation, mathematical explanation, of the relationship between two variables. So if you think about a line of best fit or a curve of best fit, then we are talking about if we have points like this that kind of model part of a parabola, okay, this is the regression function right here. That's the regression function. That's the explanation, the best mathematical explanation of the relationship between the x variable and the y variable. Okay? So in our calculator, this is what we're going to do. Now follow along very carefully. Turn this on, let's clear some things. Go to y equals, let's clear that too. Okay. Now, you see the stat button. We need to input some data into the calculator. So we're going to give it the x and the y data. Okay, that's the first thing we need to do. So hit enter here just to edit lists. And you should have some lists. They may not be empty like this. Okay, and yours may not start at list 1. That's no problem. If it starts at list 3 or 4, that's fine too. Now, if there are data in here, okay, so let's just see, okay, like this. If this is happening, in order to clear the list, go up to the title of the list and do not hit delete, please, but hit clear and then enter. And that will clear the list. Okay? All right, so what we're going to do now is we're going to input some data. Okay. Now, if you want to look in your textbook, so here's the example that we're going to quickly work through as quick as we can. Now, this is modeling. We're going to model hours of daylight, okay? And this is some data from Iqaluit, as a territory up in the north there in Nunavut. And these are the hours of daylight compared to the day of the year, okay? So starting January 1st is the first day and so on. So this is the data. On the 21st, they had 6 hours of daylight approximately. On May 21st, they had about 18.8. October, 9.24. So remember we talked about in our lesson that sine functions are very good to model periodic things and things that happen on a yearly cycle in nature, very periodic, so that sine or sinusoidal graph is very helpful for that. So we'll cut to the chase. We're going to put this data, these lists, into the calculator. So back to the calculator we go right here. And list 1, I'm going to make my x, okay? So let's say that this is the x, and why is this the x? Because these are calendar days. We start with a calendar day and we take a measurement, right? So the point or the value that you start with is your independent variable, okay? You don't say, okay, I'm going to think of a day that might have 20 hours and I'm going to then look at the calendar and find out what day that is. No. You're going to set this out. You're going to say, on this date, I am going to measure how many daylight hours we have. So this is the independent, that's x. So here we go. Again, stat, enter, and you get the list screen. These should be cleared by now, and what I want you to simply do is I want you to put in the data, that's these top row of numbers, into this list. So you do that by going 21, and it'll show up down there, and hit enter. And you keep going, 52 is the next one, enter, and so on until you've got all of them in there. So once you have that filled, we'll go over to list 2 and we'll put in the actual hours of daylight for each of those days. So it's important that you got to make sure that 21 goes with 6.12. So on your calculator, make sure 21 and then across from that, right, the first one that matches up with that is the 6.12. Okay, so do the same thing for the second list there. All the data into your lists there, okay. So get that back to screen. Then you want to make sure that you're not missing anything, okay? If you have one more data entry in one of the lists, your calculator is not going to be able to do anything. Okay, it's going to say there's an error. So make sure that you've got everything accounted for. You can run back up your list. So now that you've got everything in your lists, list 1 and list 2 are populated. What we're going to do is we're going to try and graph these points first. Let's graph the points. How do we do that? Well, we're going to turn our statistical plots, we're going to turn one on. So go to second function y equals to get to this screen. You enter, and you're going to hit enter again to turn this one on. All right? Turn plot 1 on. So second function, y equals, enter. We're going to turn it on. Now, you're going to want to just have the dots, okay? You don't need to have all these bar graphs and all that sort of stuff. So you can just skip down and make sure this one's highlighted. Now, this is important. If you put your x values, that's the top row, into list 1, then this is what needs to show up for you. X list, list 1. If you need to change that, you go second function, the number 1. See, list 1 above there? And then you can put in list 1. Then you go down here, second function, list 2. See that? Or if you were 3 and 4, then you got to put those in. Everyone got that so far? All right. Now, the other thing, before you hit graph, you might hit graph and the points might not show up yet because you got to make sure that your window is open properly to see. So let's go to window, and the x values, look at that, they range from 21 to 355. So x min, let's go like 15 maybe. X max, let's go maybe 360. All right, we need just a little bit more domain than we have points. So we'll do that. And then down to the y. Okay, where do the y go? It goes from 6, goes up to 21-ish, and down to 4. So why don't we go from maybe 2, and then the highest point that we see there is 21, so let's go maybe 25 even. Okay, so you can just quickly look at your data and set your window. So that's again under the window button right there. Now, you can graph, and we'll see what happens. Okay, so I have this set up on my calculator. You probably don't. All right, I have the table on the right. So how do we fix that? If this happens, you go Mode, and you see down at the very bottom, I have Graph Table selected. So go down to the bottom and just select Full. Okay, this is a good idea so you can have the full screen is all graph. So again, that's Mode. Go right down to the bottom, highlight Full, and then hit Graph, and this is what should show up. So once again, we've got our lists, stat, enter. There's your lists. We went to second function stat plot up here. Those are on. You enter to go into that and all that. All right, this is all set up for you. You hit graph, and there you go. So what this might look like to you is maybe a bit of a parabolic function, right? Like a quadratic. And so it would be really nice to try and come up with some kind of equation, and this is where the regression function comes in, to model this data that we see right here. Now, if we go to the textbook, you'll see that they've sort of done this. They've plotted the scatter plot, right? And they did some calculations to answer the questions. I'm not going to do that right now. But how do they come up with this graph right here? I'm going to show you. Okay, I'm going to tell you right now how they did that. So, get back to our calculator. Let's bring it over here. Okay, so what we do now is we go to stat. Okay, again, statistic. The regression function is in the statistical. So we go to calculate, so that's right cursor over here to the calculate menu, and you see all this crazy stuff. Okay, so we are going to try to get a quadratic function. So you see how there's number 5 is quad reg. That's quadratic regression. And you're going to ask the calculator to try and come up with a function that will model this data. So again, that's stat, over to calculate, and then hit number 5, or cursor down to number 5 and hit enter. And this should show up on your home screen. You're not done yet, because you have to tell the calculator which lists to draw the data from. So it doesn't know right now that you want it to put a function together for those dots, and for those points. So we have to tell it that. So let's go like this. We go second function, 1, to say, hey, I want you to draw, x is going to be list 1. Then we're going to do comma. The comma button is right above the 7. And then we're going to go, for the y value, I'd like you to do list 2. So second function 2. Then, now this is something that you might not hear from other teachers or from other classes, but I'm going to show you a shortcut to actually doing everything all at once. So you're going to hit comma again, and you may have to rewind this, you may have to hear this again later. But I'm going to show you how to put all of this data for the function into the y equals, so you don't have to copy it. And what we do is this, you go to varse, okay, varse, and then cursor over to y varse, and then you'll see function, hit enter, and then you have this. And you can tell your calculator to put all of this data for the regression function right into the y equals so you don't have to copy it. And so I'm just going to put it into y1, so hit enter, and you should see this on your screen. Okay? And then you hit enter again to say that you're all done, and the calculator will think for a second, and it will show you this stuff. Okay? Which is super, super cool. Now, before you go anywhere else, let's just take a look at this screen. The calculator has calculated for you a quadratic function, that's standard form quadratic, right? Where the a value should be this. Very, very small, -5 point whatever times 10 to the -4. Also, the b value should be this, 0.18119, so on. And the c value, this. If you write that function, if you input that function into your calculator, which we actually already did, look at that. You see, it's on the y equals screen. So now it's going to graph this over top of the points. And once we get to this point, now you can just say, hey, let's just graph that, and look what happens. The calculator, now believe it or not, that is that's the best fit for quadratic. Okay? For quadratic. Now, it's a little bit different than this one, though, isn't it? Quadratic happens a lot. That looked like a quadratic, maybe, to us. But what is a better approximation for this stuff here? And what did we talk about? Yeah, in this section we talked about periodic functions. So let's go back to stat, calculate, and let's see if there's any. I just saw quad there. Well, cubic, does that count? What else? What other options do they give us? Let's see. Oh my. Look at this. Way down at the bottom, sine reg. And that is a sinusoidal regression. All right? So, what we're going to do is we're going to hit enter, and we're going to do the same thing we did before for the quad reg, because we actually decided that this quadratic parabola actually doesn't really fit so well. And you look over here, it's like, hey, they got something else, and that certainly actually looks like a sine. So, let's go back and, quit. Okay, so back to your home screen, second function, quit. We'll do second function line, list 1, comma, list 2, comma. We're going to go to vars, over, enter. And now let's put it in another one. Let's do y2 so we can compare them. Okay? And so now when we hit enter and let the calculator do some thinking, lots of thinking. Here is the data, or the numbers, the values for A, for B, for C, and for D, for the sine. And if we check our y equals screen, look at it's already populated all those numbers in there. Saved us a bunch of time. And now if we graph, it's going to show the points, the quadratic, and the sine function, and we'll get to see which one we like better. So there's quadratic, and here comes the sine graph. Whoa, does that seem to fit the graph, the data a little bit better? Okay, so, okay, I'll come help you in a second, but just let me finish this here. So what we can do now, we can clear off the quadratic one, and then we can just see the points and the sine. All right? So I'll go over this one more time really quickly. Stat, enter, to get to your lists. Populate your x, your y. Then go to second function y equals to plot the points. Make sure those are on, and then you set your window, right, to make sure you can see all the points in your window. And you graph that, and the points should appear. Then stat, calculate, and you want to pick your regression function that best models what you see, and we thought it was maybe the quadratic, but now we've decided that the sine is definitely better, and of course that's better. And they actually have a cos there, don't they? But we did a sine. I don't think there's a cos for an option here in our calculator. So it's just sinusoidal, really. And then we do the list 1, list 2, right, like on the home screen here. It doesn't show up now, but list 1, comma, list 2, comma, y2. And it'll put everything in the calculator for you, and it'll show the points and the graph. Now, we can get information from this graph pretty easily. Second function, calculate. Let's do a value for x. That's this domain. So let's say we wanted to know what the daylight hours were for on day 74. Okay, that's March 15th, day 74. Let's say we wanted to find that out. I don't know if we have that in our list. I don't think so. So we go 74, and we find out, where is it? Right here, see? It uses that line of best fit, or that curve of best fit, to say, on March 15th, you should expect 11.75 hours. Okay? All right. One more thing. If you want to find out which day or days would have a certain number of hours, if you want to start with y, this is what you do. Go to your y equals, and let's say that you want to, I want to find out which days have 20 hours of daylight, maybe way up here. Which one has exactly 20 hours of daylight? And from our data, we have close to 20, but we don't have exactly 20. This is how you would do it on your calculator. You would pump in a y equals 20 and graph that on top. Okay, so that's a bad example because it looks like our line of best fit doesn't actually work there. So tell you what, let's do 11. Okay, let's graph that. There's 11. And then what you can do is you can find the intersection points, and that will give you the 2 days in the year that you would expect 11 hours. Okay? And how you do that? This is a whole lot of information in this one lesson, but calculate intersect. This calculate menu is pretty awesome. Calculate intersect, and the calculator will say first curve, yep, and it'll pop to the next one and say, hey, is this the second curve you want me to calculate the intersection point? Yep. And guess? No, the guess, you have to move your cursor over to one, closer to one of the intersection points so it knows which one you're looking for. So I'm going to do this, over there, and hit enter for guess, please, and it'll tell me, okay, 11 hours on the 68th day. Okay? So that's how to enter lists and some regression and extra stuff, okay, for this 5.4.